Hi, I'm back. Well, I know I told you that I was coming back for the analyzing data, but I actually wanted you to do that one on your own. But I will be back for the building a model. Okay, so right now we are at building a model, and I'm going to walk through Storm 2 with you. Okay, so if we were in a classroom setting, you would have a paper out that would look like what is below, and we would be building models on the paper. Okay, but since we don't have that, we are doing it via how I'm trying to edit the models so that you have a step by step on what your models would actually look like if we were in real life. So this is the before of Storm 2. So before and after is what it's showing us. It is showing us our surface water, which is what we showed in our models last week. It is showing us our water vapor and where we are in the troposphere. Remember, the troposphere is the first layer of our atmosphere right outside of our Earth, okay? So it's showing us how far are we going into the troposphere depending on the temperature or the wind or the lake, okay? But because we are focused on the temperature this week, we are looking at, does a higher temperature make our parcel rise higher in the troposphere or not at all? So we look at our before picture and then we see that the high temperature before the storm was 81 degrees Fahrenheit. Okay, so that's like pretty hot. That's what it would be on maybe like a summer day, but it's not like excruciating hot. It's not like in the hundreds, right? So it's moderate rainfall and warm temperature. So here I'm looking at storm 2. There is high air parcel temperature, right? It's warm, and it's 81 degrees Fahrenheit. And what I show is arrows coming out of the air parcel because energy is pushing out of the air parcel, right? When there's that energy transfer of hot air in the air parcel and cooler air around the air parcel. So energy is transferring out of the air parcel, and it says high temperature equals 2 arrows. So maybe if I were to draw low temperature, it would be 1 arrow. If I were to draw really, really high temperature, it would be 3. But just high temperature is 2. Okay? So I have 2 arrows that are showing warm or high temperature. So because there are 2 arrows going out of the air parcel, that means that there is a medium amount of energy transferring out of the air parcel. So in this yellow box, it says arrows represent the transfer of energy out of the air parcel, right? And since it's a high temperature, we know that there's just a medium amount of energy being transferred out, and we're representing that with 2 arrows. The higher the air parcel temperature, the higher the air parcel will rise into the troposphere. Okay, so the hotter that the unit of air is, the higher air parcel temperature, the more it is going to go up into the troposphere. And that is because if it is hotter, if it is higher temperature, it has more energy to transfer out, that it can keep going, keep going, keep going before it hits equilibrium. So it shows me level 1, level 2, level 3. And it also shows that the parcel temperature is high at 81 degrees Fahrenheit and it reaches level 2. So it is not hot enough to go all the way up to level 3, but it is hotter than to just be stuck at level 1. So right now, this air parcel for storm 2 is at level 2. It has a troposphere temperature of low or medium. Its liquid water is medium, and its air parcel temperature is now low. So that's what once the energy has transferred, right? We're in the after box here. As the air parcel moves up in the troposphere, it transfers energy out and gets cooler, right? So the air parcel is hotter, it's hotter, and then it's transferring energy out, and it's slowly getting cooler as it's transferring its hot energy out of the air parcel. it becomes equal with the outside air at level 2. So we've talked about what equilibrium means, but if you have forgotten, equilibrium means that it is equal. So now the air in the air parcel and the air surrounding the air parcel is the same. See here it says troposphere temperature low, parcel temperature low. Low and low, that's at equilibrium. So to put it all together, we are showing that before our air parcel was high, it was at a high temperature. Our cloud was at a high temperature. It was hot. It was transferring a medium amount of energy out of the cloud and into the surrounding air. Medium energy is represented by 2 arrows. As it moves up into the troposphere, it's transferring out all that energy. And once it hits equilibrium, where it's low troposphere temperature and low parcel temperature, it stops. And it stops at level 2. So now you're going to answer which part of the model represents the energy transferring out of the air parcel. Refer back to step 3. So this is a good clue right here. Refer back to step 3. These are all labeled. You're going to go back to step 3, reread this, and make sure you're reading those clues, and then go back and answer that question. Okay? I am not going to walk you through the next storm, but if you are getting confused at what everything means, please come back to this video. The steps are the same, however, the temperature of the storm is going to be different. Good luck, and please reach out if you have any questions.